afternoon. I'm Mr. Harris, and I'm here to do some A-level work with those people in Year 11 who are looking to do their Year A-level next year, and the people in Year 12 who are looking to move into Year 13. The topic I'm doing today is in the second half of the syllabus, so it would be suitable for Year 13, but anyone who's in Year 11 wanting to go in should be able to follow most of what I do today, because it is introducing something new and it might be useful. So this could also be a useful lesson for anyone who's started the topic, because it doesn't have to be live. Obviously, I've got a few people live with me today, but that could well be, there'll be people watching this before an exam or when they're doing this topic themselves. So hello to all people joining me. If you have any questions, as usual, you've got 3 ways of contacting me, but you can also put a comment in the link below, and I will look to get back to you as soon as I possibly can. So just what is algebraic division? Algebraic division is a way of using the things that you possibly already know from long division, but applying it when there's an algebraic situation. Now, in algebra at A level, I would expect that I wouldn't have to explain that a fraction is a division. So in this case, we can rewrite this expression as minus 6x cubed minus 4x squared plus 3x plus 2 divided by 3x plus 2. And I lay it out as follows. We draw our bus stop method and minus 6x cubed minus 4x squared. Now I will mention as I'm going along, if you were doing something that didn't have one of these, I would add it in as a naught. So for example, if I was dividing x cubed plus 4x minus 9, you notice there's no x squared term. I would write this as x cubed plus naught x squared plus 4x minus 9, just because it makes the algebraic division easier. So I'll skip that, undo all that, because that's just a what if, a hypothetical, and I'll go straight on with the question we're doing here. 3x plus 2. So what we're looking to do is we're looking to divide this whole thing by 3x plus 2. And in order to do it, you look at how can I make the first thing that I come across. How can I make that 6x cubed? And the way I need it is to make 6x cubed, I need to multiply 3x by minus 2x squared. Just to confirm, 3x times minus 2x squared gives me minus 6x cubed. But it also gives me minus 4x squared as a extra bit, because it's the 2 times minus 2x. Now, it might be misleading because you're like, well, I've already got the thing I want here. That won't always be the case. But if we do a subtraction here, minus 4x squared minus 4x squared, we get the 0 that we're expecting here, but we also get a 0 here. Okay, and I've got ink to shape off, so I'll just get rid of that. That means I bring down, I need 0x squareds, so I'm going to put plus 0. And that's going to give me 0 and 0. 3x minus 0 gives me 3x. So I'm going to want 3x, which means I times by 1. And so that's 0x. And 2 lots of 1 is 2. And when we do this, 2 minus 2 is 0. So we're left with no remainder. This is where the remainder would be. Now, the factor theorem says that if it's got 0 remainder, that would be a factor. We can verify this. We can verify that a factor, the factor theorem states that if there's no remainder, x equals minus 2/3 must be a factor. And if we put this in, f of minus 2/3, we can put minus 2/3 in as every value of x. So we can put minus 6 lots of minus 2/3 cubed, minus 4 lots of minus 2/3 squared, plus 3 lots of minus 2/3 plus 2. And we will get minus 6 lots of minus 8 over 27, minus 4 lots of, must be positive, square numbers are always positive, so 4 over 9, plus minus, in fact, because it's a plus times a minus, so it'd be minus 6 over 9 plus 2. simplify all this, we get cancelling down, that will go down not to 9s, so it will go to minus plus, because minus 1's a minus, plus 24, but divide by 3, we're going to need 16 over 9, minus 16 over 9, that's useful, minus 2/3 and plus 2. This is frustrating because it's not giving me what I wanted, but it's also a chance to show that there must be a mistake in here somewhere. So I've put minus 6 lots of minus 2/3 here, and 2 8s are 16, 3 cancels with the 27 to give us the 9, so it's definitely 16 there. It's definitely 16 there, so they do cancel out. Have I written it all correctly? And x equals minus 2/3. 3 lots of minus 2/3 is minus 6. It's not over 9. That's where I've made my mistake. Should not have made that over 9. It should be over 3. And it's always useful. I actually like showing students me making mistakes because it shows how you get out of making mistakes, which A-level students often do, and so do I. So that is how you would do this algebraic division, and it proves that this is the answer 0, which shows that I did it correctly. You wouldn't be expected to do this every time, but I'm trying to show you, I did say in the video, this is a remainder and factor theorem. It's a way of checking you've done the division correctly. So you can see that the division of this, and the way you lay out your answer, so to speak, I don't like the word answer, but the way you lay out your thing is that this would equal minus 2x squared plus 1, because that's the bit that is the answer, or the value. If there is a remainder, there'll be an extra bit, which will come up probably in the next question. So let's move on to the next question. Divide 9x squared. So we're going to go about this exactly the same way. We're going to put 9x cubed plus 6x squared plus 7x minus 1 and divide it all by 3x plus 1. So in order to divide it, we're going to look at how can I make 9x cubed. And to make it, I'm going to need to multiply it by that and by that. So I think to make 9x cubed, I need 3x squared. So that's going to be put there. 3x squared will give me the 9x cubed I wanted, but it also gives me plus 3x squared. And this is the good thing about this one. It shows you it won't always be nice, because the next thing you do a multiplication, which is weird because this is how you're doing division, is a multiplication followed by a subtraction. Then we're going to do 6x squared minus 3x squared is 3x squared. We then bring down the plus 7x and do the next line. So how am I going? So we can rub out this 3x. What am I going to multiply by 3x to get 3x squared? Well, should be quite straightforward. I'm going to multiply it by just x, because if you times it by x, I get 3x squared, but I get plus x. And I didn't want plus x, I wanted 7x, so we do another subtraction. Remember, each time we get to a line, we subtract the top one from the bottom one, giving me 6x. This is naught. This shows that we've dealt with that bit. We now need 6x. So I'm going to, instead of timesing by 6, what do I multiply 3x to get 6x? It's going to be 2. So I'm going to be timesing by plus 2. That gives me 6x, bring the minus 1 down, and 6x, but it would also give me plus 2. Minus 1 minus 2 is minus 3, and this is the remainder. Now, first thing I'm going to do is write out what my answer would be. Give your answer as a sum of the quotient plus the remainder divided by the divisor. So, it's going to be 3x squared plus x plus 2, and then this is the bit that it's talking about the remainder divided by the divisor, plus, minus 3 over 3x plus 1. That is the divisor, because it's what we're dividing by. So if you get a remainder, you have to put the remainder over the top of the divisor because it hasn't been divided yet. And this is your final answer. This would be what you'd write as your final answer. Now, I did mention at the start of this video, this is going to be the remainder theorem as well. Well, the remainder theorem states that if I put find the function of, if this was 3x plus 1, if 3x plus 1 equals 0, I want x to equal minus 1/3. Notice how 3 times minus a third is minus 1 plus 0 makes 0. Whatever makes this function, whatever makes the divisor 0, we're going to put in. And if we've got it correctly, the remainder theorem states that if I've done this right, the remainder should be minus 3. So let's put this into the original expression. We're putting it into here. I'm going to change the colour so you can see exactly where we're putting it. I'm putting it into this expression. So we're going to go 9 lots of minus a third cubed plus 6 lots of minus a third squared plus 7 lots of minus a third minus 1 equals 9 lots of minus 1 over 27 plus 6 lots of plus, remember when you square a negative number, both of you plus 1 over 9 plus, minus 7 over 3 minus 1. That cancels to minus 1/3. This cancels to plus 2/3, minus 7/3, minus 1. So we've got minus a third, plus 2/3, minus 7/3, I think, is minus 8 plus 2 is minus 6/3, also known as minus 2. Let's simplify that. Minus 6/3 minus 1, which is the same as minus 3, and you will notice this is what the remainder theorem is. This tells me I've got my calculation correct, because the remainder, when I put minus 1/3 in, and I got minus 1/3 because that's what makes the divisor 0, is the same as the remainder I got when I did my algebraic division. You don't have to do it, but it's a good way of checking that you've done the division correctly. This is how algebraic division works, so it's just a case of making sure you know what you're doing. And while you're first learning, I don't see the harm in it. Now, you'll notice in the description below there is a link to this worksheet that it's got solutions and work solutions below it as well. I do recommend, if you want to get good at this, you need to download it and practice the questions. Practice makes permanent, in my view. Not perfect, but it does make it so that the knowledge goes into your head and stays there. If you're a year 11 wanting to go into doing A-level, this is a fantastic way of developing your skills early, so by the time you come to this, you're like, I can remember parts of it, or I can remember some of it, and it makes you stronger. If you're a year 12, this is the time you need to be doing this. You're going to come back in possibly September, hopefully. Some of you will be back already. I'm teaching my year 12's the year 13 course already on a Friday, but that's only once a week, and normally you end up with 6 lessons a week, or maybe 7 lessons a fortnight, something like that. So we need to make sure that you're not falling behind and making sure that you cover the material. This might also be a video you're watching when you're revising. Hopefully it makes some sense to you. I'm trying to make it make as much sense as possible. I've got 2 more questions I'm going to go through today. Here is a question which is exactly the same question but laid out in a different manner, because it's an important skill as an A-level student, to be able to work out the thing. This is asking you to do algebraic division, but it doesn't mention division, it doesn't mention divisor, it doesn't say remainder, it just says given that this is this, find the values. The clue is this is a division. No, I didn't mean to drag that. The clue is that this itself is a division. So we're going to perform the division, and often when you see questions like that, given that, when you see a question that says given that, and then there's an identity, you've got to use the left hand to find the right hand. Use the left hand side. I often use LHS and RHS to stand for left hand side and right hand side. So I'm going to do the division myself manually. 2x cubed plus 3x squared minus 4x. I am quickly checking the chat in case anyone is watching. It may well be that I'm doing this on my own and talking to no one. That's fine. But if anyone is with me, I will happily answer any questions or pause if anyone has any live questions. If not, I'll look in the comments below the video throughout the next few months and years, who knows. So we're dividing by x plus 3. So when you've got how do I get 2x squared? I need to multiply this by by 2x squared, because I want to make 2x cubed. So I'm going to write that above there, 2x squared. That's going to give me 2x cubed and 6x squared. This is the first time we've got a negative. 3x squared minus 6x squared is minus 3x squared. How do I get that? Well, to multiply something by x and get minus 3x squared, I want to bring this down as well, by the way. I'm going to need to multiply it by minus 3x. That's going to give me minus 3x squared. You notice this line is always the line of the multiplying bit. Minus 3x, but it's also giving me a minus 9x. And this is possibly the biggest area for mistakes in algebraic division, so it's massively important that we're paying attention here. Minus 4 minus minus 9 is the same as minus 4 plus 9, which is 5. This, if you make a mistake in your algebraic division, this is the most common place that it's going to be made, in remembering that when you minus a minus, it ends up being addition. So you've got 5x. How do I get 5x? I'm going to need to do plus 5. But that's going to give me, bringing down the plus 5, that's going to give me 5x, and it's also going to give me plus 15, which is going to be a remainder of minus 10. Then my solution is therefore, comes from these two bits here. It comes from here, and it comes from my remainder. So we write my solution out as 2x squared minus 3x plus 5 and then minus 10 over x plus 3, because we write it over the divisor. Now this is the key bit. Loads of people don't do this, and I'd love to see anyone who's used my videos gets themselves in the habit. This is not complete. To complete a question like this, you always state, even if it doesn't tell you to, state your values of A, B, C, D, just to show that you've finished the question. So A equals 2. B equals, this is A. B is there, so it's minus 3. Don't forget your minuses when you're looking at the letters. C equals this one. And D equals the minus 10 on top. But I did say we could use the remainder theorem to check our answer. I wouldn't expect you to always do this, but you can. What makes this 0? X equals minus 3 does. So let's use the remainder theorem, and if we got it right, f of minus 3 should equal minus 10. Let's verify using, remember, I'm using this thing, this equation. So we get 2 lots of minus 3 cubed plus 3 lots of minus 3 squared minus 4 lots of minus 3 plus 5 gives me 2 lots of minus 27 and 3 lots of 9, and then plus 12 plus 5, so it gives me minus 54 plus 27 plus 12 plus 5 gives me minus 54 plus 27 is minus 27, minus 27 plus 12 is minus 15, plus 5 is minus 10, and I am a happy person. So I put w to the power of 5. Now, in a square bracket, this is geek speak or programming language speak. I'm a computer scientist as well as a mathematician. If you put things in square brackets, they are comments. They don't contribute to the math themselves. My comment here is w to the power of 5. It's geek speak for which was what we wanted. www. And you can see that's how we're going to do those. So it's just a way of saying, oh, that's what I wanted. You can also write QED, which stands for Quaderat Demonstrandum. Thus, it has been demonstrated in Latin. Never too late to start becoming a geek. I think it should be embraced in all people. Here's the last question I'm going to do with you today, and you'll notice it's not always a nice number. Now, the thing is, I can't easily here use the remainder theorem because I don't have a single value for x. I have 2 values for x. But what I can do is work through the question just like before. 4x cubed minus 5x squared plus 3x minus 14 all divided by x squared plus 2x. And don't be put off by the fact that it's a quadratic here we're dividing by. How am I going to make 4x cubed? Well, I'm going to make it by multiplying this by 4x. And remember, if I times by 4x this time, I'm going to have 3 terms. 4x squared, x cubed, plus 8x squared minus 4x. Then we do our subtraction. That's gone to 0, but minus 5 minus 8 is minus 13x squared. And then minus minus is a plus, so we've got plus 7x. How am I going to now make the minus 13x? And remember to bring down your the minus 14 as well. Well, to get the minus 13x, I'm going to need to do minus 13. No difficulties with that one. That's going to give me minus 13x squared, but it's also going to give me minus 26x, and it's also going to give me plus 13. So when I subtract, 7 minus a minus is 33x, and 14 minus 13 is minus 27. This gives me a solution of 4x minus 13 plus 33x minus 27 over x squared plus 2x minus 1. But as I said before, never leave your answer without saying so. A equals 4, B equals minus 13, C equals 33, and D equals negative 27. Don't forget to get the signs the right way around. I hope that this has helped teach you to do algebraic division. It's shown you how you can use the remainder theorem to check, and it's talked to you about it in a sense that makes sense. Please feel free to contact me if there's any questions. Please do put comments in the video below, or drop a like if it has become useful. If these videos are useful to you, I'll try and do them throughout the A-level year. It may be that you didn't watch it live. I'm not sure many people have, but that's not a problem. I'm not here just to... It's not about me. It's about trying to be helpful in lockdown or in whatever we find ourselves in September and beyond. If you are getting anything out of this, then that's fantastic. I've been Mr. Harris. You haven't. Look after yourselves and take care.